China's Chang'e 4 moon rover mission is back in action on the lunar far side. It's day 31 on the moon for Chang'e 4 and the U-22 rover. China's Chang'e 4 mission is back in action for its 31st lunar day of activity on the far side of the moon, with the U-22 rover set to scope out a new crater. Both the mission's lander and the U-22 rover have resumed science activities following sunrise over their location in Von Karman crater on the far side of the moon. U-22 awoke on June 14th, while the lander restarted its activities 13 hours later on June 15th. The U-22 rover had remained stationary during Lunar Day 18, while teams back on Earth upgraded ground stations in preparation for the Tianwen-1 Mars mission, due to launch in late July or early August. Upgrades to the tracking and command facilities at Jiamusu, northeast China, and Kashi in the northwest were completed on June 13th. That means that normal roving service can now resume. While the rover has been stationary, the U-22 science team have identified a nearby crater for examination. The 4-foot wide or 1.3 meters, 8-inch deep or 20 centimeters crater contains reflective material which may be similar in nature to suspected impact melt glass the rover discovered in 2019. After checking out the crater, U-22 will continue its journey northwest from the Chang'e 4 landing site. U-22 has driven a total of 1,469 feet or 447.68 meters since setting down on the far side of the moon in January 2019. NASA's Lunar Reconnaissance Orbiter, LRO, has meanwhile been imaging the Chang'e 4 lander, also showing the progress of U-22. An image taken in January 2020 shows the lander cast in a shadow as well as the much smaller U-22 just north of a crater. Incredibly, faint tracks made by the rover can also be observed in the images returned from the orbiting Lunar Reconnaissance Orbiter. Both the Chang'e 4 lander and U-22 rover have exceeded their design lifetimes of 1 year and 3 months. Lunar activities will continue in June. The spacecraft will then power down to protect against the harsh cold of lunar night, which will begin with sunset on June 28th. China is also preparing a lunar sample return mission, Chang'e 5, to launch in the final quarter of 2020. Chinese moon rover peers beneath the surface of the mysterious far side of the moon. U-22 keeps showing things that have never been seen or discovered before. China's far side moon mission has turned its history-making gaze underground. The Chang'e 4 spacecraft touched down on the floor of the 115-mile-wide Von Karman crater on January 2, 2019, and became the first probe ever to ace a soft landing on the moon's mysterious far side, which forever points away from Earth. A rover called U-22 or Jade Rabbit 2 rolled off the stationary Chang'e 4 lander just hours after touchdown. The two solar-powered crafts have been taking the measure of their exotic surroundings for more than a year, using a variety of scientific gear, which provides us with unprecedented views of the lunar far side's surface. Views that have been provided now extend to the subsurface of the moon, courtesy of the first published results from U-22's ground-penetrating radar instruments. Chang'e 4 scientists revealed that the structure of the gray dirt beneath the rover's wheels, as gleaned from radar data gathered during U-22's first 2 lunar days of operation. Each lunar day is about 2 Earth weeks long. U-22 and the Chang'e 4 lander hibernate during the brutally cold lunar nights, which also last 2 weeks apiece. The researchers discerned 3 distinct layers beneath U-22's section of the von Karman floor. The top layer, which extends about 39 feet or 12 meters down, consists of relatively uniform lunar regolith soil, with a few large rocks mixed in here and there. The second layer, which goes from about 39 feet to 79 feet or 24 meters deep, harbors coarser grained materials and greater numbers of embedded rocks. The third stratum, which goes down to at least 130 feet or 40 meters, the radar couldn't reliably penetrate any deeper, features alternating bands of coarse and fine-grained material as well as embedded rocks. This data indicates that the subsurface internal structure at the landing site is essentially made by low-loss, highly porous granular materials embedding boulders of different sizes. This particular structure highlights the fact that the region has a violent history. Given such a strong geological constraint, the most plausible interpretation is that the sequence is made of a layer of regolith overlaying a sequence of ejecta deposits from various craters, progressively accumulated after the emplacement of the mere basalts on the floor of von Karman crater. Those dark mere basalts are evidence of ancient volcanic activity, which flooded von Karman with molten rock about 3.6 billion years ago. Early astronomers thought that these big patches on the moon were bodies of water. U-22's newly published observations also show that ground-penetrating radar can be a valuable tool for other lunar surface crafts going forward, especially on the little-known far side of the moon. Extensive use of this tool could greatly improve our understanding of the history of the lunar impact and volcanism, and could shed new light on the comprehension of the geological evolution of the moon's far side. The Chang'e 4 lander was originally designed to operate for 12 months, and U-22 for just 3 months. Both crafts have therefore already exceeded their warranties, and both are still going strong. The duo recently woke up to begin their 15th lunar day of science work. Chang'e 4 is part of China's ambitious Chang'e program of robotic lunar exploration, which is named after a Chinese moon goddess. The next mission up, the Chang'e 5 sample return effort, is scheduled to launch later in 2020. Has been a review of China's Rover mission on the moon. We have looked at the Chang'e 4 and the U-22 Rover, which continues to gather information and return data to the Earth and to Earth's scientists and researchers as we continue to learn and gather data about the far side of the moon. We previously did not have sufficient information, so therefore this mission is proving its worth, and hopefully our knowledge and understanding of the dark side of the moon will continue to grow and expand. Now like, comment, share, and subscribe. Leave your feedback down below. Let me know what you think about China's efforts to explore the far side of the moon using robotic technology. Thanks for watching the Learning Academy. Subscribe if you have not already done so.